This practice problem is also from page 130, and this is number 67. So I've already set this up with the drawing here. The drawing's also in your book. So it says in the drawing, the weight of the block on the table is 422 newtons, and that of the hanging block is 185 newtons. Ignoring all frictional effects, hooray! And assuming the pulley to be massless, find A, the acceleration of the two blocks, and B, the tension in the cord. So what we're looking for here is A, the acceleration, and B, the tension. So we should know by now that the acceleration of each block is going to be the same. This one's just going to be in the x direction, and this will be in the negative y direction. And the tension also will be the same. Since this passes around a massless, frictionless pulley, the tension in this part of the cord is the same as the tension here. So let's go ahead and fill in some forces. Probably the easiest way to do this problem is to treat this system as one single body. So if we look at it as one single body, then we can consider the tensions as within the system, and they'll cancel each other out. And then the only other thing left will be the weight of this block pulling down. We'll call this block 2, and this will be block 1. So this will be FG2. Okay, and then this one also has a weight which points straight down, but the normal force points straight up and cancels it out. So we don't need to be concerned about that. Alright, so looking at this as one system, we can say the F net for the system equals mass times acceleration of the system. So the net force for the system will just be Fg2. And the total mass of the system will be mass 1 plus mass 2. So our acceleration becomes Fg2 divided by m1 plus m2. So at this point, do we need to find Fg2 or do we need to find the masses? So a lot of problems give you the mass of the objects and you have to find the weight. But this one gave us the weight, so be careful and really read carefully what it's giving you. It says that the weight of the blocks is this, and another clue is that these numbers are in newtons. So that indicates that that's the force of gravity, not the mass. So we need to calculate the mass. So the mass of block 1 can be calculated using Fg. We'll do this off to the side. Fg equals m times g, right? So m is just going to be Fg divided by the acceleration due to gravity. So m1 is going to be 422 newtons divided by 9.8 meters per second squared. So m1 works out to be 43.1 kilograms. Okay, doing the same thing for mass 2, m2 will be 185 newtons divided by 9.8 meters per second squared. I said newtons, but I didn't write it. There we go. m2 then becomes, where did I write that one? 18.9 kilograms. Alright, now that we have m1 and m2, we can plug them in here. So now A equals Fg2, which is our weight, so that's our 185 newtons, divided by mass 1, 43.1 kilograms, plus mass 2, 18.9 kilograms. So working that out, you get acceleration equals 2.98 meters per second squared. So that answers part A. Okay, on to part B. So this was part A here. Let's label this. On to part B. Part B is asking us to find the tension. So we don't really need to look at both blocks to find the tension. We could look at one or the other. So looking at, usually we look at the hanging block. That's what we've usually done in class, but you can also look at block 1. So if we looked at block 1, that's actually maybe a little easier. Let's make a new color. Okay, so for block 1, I thought I made a new color. There we go. F net equals MA. And block 1, the reason why I said it was a little easier is because the only forces acting on block 1 are gravity, the normal force, and the tension. And in this case, gravity and the normal force will cancel out. So our net force ends up just being the tension. So that equals the mass of block 1 times A. And we've already found mass of 1, so we can just plug that in. 43.1 kilograms times the A that we found in part A, 2.98 meters per second squared. If we calculate that, we get 128 newtons. So if you did it the other way with the hanging block, you should get pretty much the same thing. And that answers both parts of the question.